Okay, guys, packet. Find your packet. Some of you have already stamped because you did your doodle notes on Friday. Find your packet, get it out. It's 11.1, 11.2, 11.4. Yeah. Yeah, you can go. Okay, so as the parts of the circle, guys, I will come by and stamp. I'm really going to stamp it once. If I haven't stamped your doodle page, when we get to the second page, I'll stamp on that check. So it says parts of the circle. It says the word circle comes from the Latin word circulus, which means disc. All right, so basically your doodle to-do list says first label a central angle. I did that, and I wrote the definition because this is also you need to make sure you complete definitions. So underneath here is central angle, the definition of central angle underneath the circle. It says the circle is a central angle of a circle is an angle with the vertex at the center and the sides are radii. So mine was purple. It doesn't have to have the same color scheme, but you need to draw the arc and you need to label inside central angle and theta, which is the symbol that we use for the measure of an angle. Now, I asked you to have different colors because that will help you see the key points and to highlight and embellish some of the key ideas. One thing I need you to make sure you do is highlight the arc, this curve, from B to F. I did it blue. You can do it, pick a color, and get it highlighted, and label it minor arc. Because that's one of the things they ask you to label. Label a minor arc. An example of the minor arc is part of the circle, the curve that goes from B to F. If you need colors, just try to find some out of the blue box. All right, then they also want you to draw arrows to show the circumference goes around, all the way around the circle. So under here, I just did a little green squiggly line to show that that distance all the way around represents the circumference. Now you can design it differently, but just make sure you have the arrows to show the circumference goes all the way around. Label the center. I did that. That was my C. It's kind of small here, but the center is labeled C. Complete the definitions. We're going to fill in each formula, highlight, and embellish key ideas. So, some things we need to highlight: the arc, the measure of an arc. The arc is part of a circle. It's the curve, and it correlates with the central angle. Also, I added diameter, and notice that this arrow is pointing all the way across from A all the way to F. So add the diameter to your part of the circle. And then I went ahead and just outlined in a different color the radius. Also, I could put a lowercase, oops, I didn't do that. I could put, oh, it's not working. I could put a lowercase r to show radius as well. Radius is a segment that goes from the center to the edge of the circle. Okay? All right, so you have to hit your formula, so just embellish that. Yeah. But D represents diameter. Diameter is 2r, meaning it takes twice the radius, 2 times the radius equals the diameter. Circumference 2 pi r squared, 2 pi r, and area is pi r squared. And then I just said that the perimeter of a circle is the same thing as the circumference. And then I highlight the arc, so you have a definition for that. So, does anyone have questions on this page? What's being doodled? All right, we're going to the next page. All right, this is why I want you to have 3 different colors. I don't care which colors you have, and we need to have 3 different colors to show 3 different representations.
Do you have a sharpener I could use?
You can try that one, you just got to plug it in. Okay, so there are 3 types of arcs: a minor arc, a semicircle, and a major arc. A minor arc is measured less than 180. 2 endpoints. Now, if I look at circle T, because a minor arc is less than 180, I can go from A to B, and that would represent my minor arc. That's one example. So an example would go from the curve A to B, and then I would put the symbol, the arc, above it to show that. Minor has only 2 endpoints, meaning only 2 letters. That's only one example. Does anyone see another minor arc? A curve that would be less than 180. What? Yeah, so AB, or you could say BC. That's your example of a minor arc. Semicircle has degrees exactly 180. 3 endpoints, meaning 3 points on the circle that would have a degree of 180, represent half of a circle. Which 3 points could you use for your semicircle? T is in the center. I can't use that because it's on the circle. What? Yeah, A to B to C. A, B, C, and then an arc over it. That would be your minor arc. I mean, your semicircle. All right, your major arcs, more than 180, 3 endpoints. Basically here it says 360 minus the measure of the related minor arc. Okay, I'm going to start with the first arc we have, which is this AB. Okay? AB corresponds to this central angle. So basically all of this goes together with the arc AB. Does someone understand that? To get to your major arc, you're dealing with the arc minus 360. This arc minus 360. So we're dealing with what remains. So the AB is the minor arc. The major arc is the rest of the curve that remains. That means from A all the way around to C, all the way back around to B. That would be the major arc. I'm hoping you can see the difference between the big piece and the small piece. So you would write A, C, B with the arc over it. Right now, most students are struggling with understanding which one is a minor and which one is a major and labeling it correctly. All right, so the 3 major arcs are what we're going to use. We filled in our table. I need you to highlight the key information and add the second formula for length of an arc. So I'm going to give you time to get this highlighted. I'm going to come by and start stamping, and then we're going to do some examples. All right, little example that we have here. I need everyone on the, we're going to finish this page, and we're going to go straight to the practice exercise. So what do you think this lowercase m represents? Measure. Yeah, measure. Okay, guys. What do we measure arcs or angles in? Degrees. Michael, what do we measure arcs and angles in? Degrees. Okay, so our answer has to have a degree to get this answer. Now, what's the name of this arc that they gave us as an example? What's the letters that they give you? ADB. Is this a minor or a major arc? Minor. So, just to recap, if it has 2 endpoints or 2 letters, it's going to be what? Minor. Okay, so understand, if it's minor, oops, and that's the wrong color. If it's minor, it's only 2 letters. Maybe that might help you understand it. If it's major, Then it has 3 endpoints. That means 3 letters. Okay, so back to our example. How many letters do we have with this name of this arc? 3. So is it minor or major? Yeah, this is major. So right to the right of this, write that this is a major arc. Okay? And I wrote that wrong. Major arc. So if it's a major arc, what would its measure have to be? More than 180. So it has to be more than 180 degrees. That helps me make sure I'm picking the right answer. Start with the first letter, A. We're going to trace, pick a highlighter or color. Trace the arc. Order is important. Go in the order. So if this is ADB, do I have to, from A, do I go to the right or to the left? Yep, I go from A here to D to B. Highlight the arc.
Wait, do we always go to the right?
It depends on the name, like the order of the letters.
Should we go from B to F and then F to A2, or just
B to F. What do you mean B to F?
like should we like highlight the like normal things type in?
Oh, okay. So I would do that in a different color. And so if you did B to A, that's the minor. And yeah, it would go with the BFA. Because that's the central angle. Yes, yes.
Why wouldn't it go from A, B, C, and then D? Why would it go the other way?
A what? Say it again.
A, B, C, D. Why would it go the opposite way? I know. But if it's going this way, why does it have to go this way? Why can't it go the other way?
But you just said it goes from A to D to B. So if I go the other way, you're saying you're going A to B, then D, and then back to B? That don't make sense. It has to make the arc. Okay. All right, so that curve should look greater than 180. Does that curve look greater than 180? All right, so let's come up with, they want to measure the degrees. So we want to figure out how many degrees would this arc be? How big would it be? Anything you know about the circle? Yes, we have 90 degrees and a 63. All right, so since y'all didn't see this, what is the part B to E? No, B to E. The diameter. Okay, so the diameter cuts the circle in half. Does that make sense? So if I highlight this diameter B to E, then what do I know about this part of the arc, the right? 180. Yeah, over here is a total of 180, right? Half the circle. So we just need to add 180 plus that 63, and that would give me the degrees of the arc, which is what, 243. So the measure of the arc ADB is 243 degrees. Okay, so here's my challenge to you. If the green arc is 243, what would be the minor arc? How could you find the minor arc? What? 360 minus 243 would equal the BA. Okay. All right. Highlight the arc AB, the next example. Is it major or minor? Minor. How do we know?
It has two
Yep, 2 letters, 2 points. So this is minor. So we're just going to highlight that curve, A to B. And you can see that that's less than 180. Okay, here's what you need to do with your same color. This arc A to B goes with the central angle, meaning I need to figure out the angle that pretty much is eating the arc. That would be the angle from AOB. Do y'all see how it kind of makes a little pie piece or pizza piece? I need you to highlight that so that you know that they're the same color. It's the same color, Michael. I need you to pay attention. Are you on your phone?
No.
Is it out? The measure of this arc, whatever I have here, is the same as the curve. So we have to find the central angle. So what's the name of this central angle? Central angle. Come on, guys, try. Focus. What is the name of the central angle that goes with the arc AB? Okay, O is the name of the center. I want the angle. AOB. An angle has 3 parts. Okay, the vertex and the 2 sides. That measure is going to equal to the same measure as the arc AB. Do you have the measure of that central angle? Do you know what that degrees is?
No.
No, we don't. What degrees did they give you? And what does that 27 go to? Angle who? Yeah, angle A. It goes with this angle here. Oh, this one color. It goes with angle BAO or OAB. So, guys, in order for you to find the measure of the arc, you have to have the central angle. And in order for you to do that, we have to use this triangle. If I'm looking from O to A, what is that part called? O to A. All right, so I'm gonna put an R there. Radius. The part from O to B. The part from O to B. It is also a radius. So, do y'all see that we have these 2 radius here? And if they're both radius, they're going to be both congruent. Wow. All right, so I'm going to redraw this triangle. Here's A, here's B, here's O. These are the same. This is 27. I'm going to use what I know about a triangle to find my missing angle. What type of triangle is this?
45. Oh no, it's
It is not right.
no, because the 27 is isosceles.
Okay, so what do you know about a sausage triangle?
That 2 sides are the same and one's different.
2 sides are the same. There's something else you should know about a sausage triangle.
One is different.
2 angles are also the same. If you have 2 sides, you have 2 angles. So, with that being said, what 2 angles are going to be the same?
A and D.
A and B. So that means if A is 27, B is also 27.
Oh.
Now, what do you know about the sum of the angles of a triangle? Equals 180. Okay, so find the missing angle O.
Oh. I spell it. Oh. It is. It's 126.
36. 126.
All right, so questions on how do we get to 126?
No. So you just add the 2 together and then subtract it by 180.
Yes, so if this is 126, this angle here is 126, then that is my central angle. So what's the measure of the arc AB?
Oh,
It's 126, guys. The angle and the arc go together. The measure in degrees, the angle and the arc are going to be congruent. Okay, so let's do it this way. Go to the next page. 126. Yeah.
Steps, please, one minute. We have completed all.
Guys, let me make this a little simpler for you. Number one says, they want you to name a minor arc. There's more than one answer, so let's get one. Give me one minor arc. All right, QR. Okay, good. I'm going to highlight that, okay? So put QR here. And then put an arc over it. Okay, that's the minor. So the major is everything else that remains, okay? I'm just going to highlight it. Because the major is everything else that remains. That means everything from Q, U, T, S, R, okay? But how many letters do you need to name a major arc? 3. So just give me 3 that are on that major arc. Huh? SR? Okay, but I have to start from this end. I can say QTR. Oops. What's QR, QTR? What's another one? Okay, QTR is the same arc as, give me another name that's still on the yellow.
QTS.
Nope. I gotta get, if I start here, I have to end here.
Oh, QRS.
I can say QSR, because this is the start. I hit an S, I hit an R. I can say QUR. Q to U and then over to R. But Q and R have to be the beginning and end of the major. Does that make sense? All right, let's do one more. Let's say I'm looking at this major arc. Let's do QU. That's the major arc. I mean the minor arc, excuse me. What would be the major arc if QU is the minor? U what? USQ would work. UTQ would also work. Not URQ. Oh yeah, URQ would work, yeah. All right, now, the last thing is name a semicircle.
QUS.
Yes.
Wait, what were you naming in red?
The major. The minor, and this is the major. This has, it's the 3 not in these. All right, we're stopping there.